A curve C defined for x between 0 and 2 pi by the equation y equals sine x, where x is in radians, is sketched below. The region bounded by the curve C and the x-axis from 0 to 2, and the line x equals 2, is shaded. The area of the shaded region is given by the integral of sine x between 0 and 2, where x is in radians. Use the trapezium rule with 5 ordinates, or 4 strips, to find an approximate value for the area of the shaded region, giving your answer to 3 significant figures. So that's what we need to work out then. I've summarized the question here. We need to use 5 ordinates and 4 strips between 0 and 2. So our integral then, which will be the integral y dx, we can say, between 0 and 2, the formula is h over 2, y0 plus yn. Now we've got 4 strips, so there's 5 ordinates, so n will be 4, plus 2 of all the y values in between, isn't it? y1 plus y2 plus y3. So there's our formula according to the trapezium rule. H is equal to b minus a, so that's 2 minus 0 over n. The number of strips is 4, so h is a half. So a half over 2 is a quarter, so I'm going to put that in straight away here. That's okay, so that's a quarter then. Now we need our 5 ordinates, so let's do x0, x1, x2, x3 and x4. So x0 is 0, and we're going up 4 strips, so they'll be divided by a half, won't they? As we said, it's a half, so they go up in 0.5s then. And then we're dealing in radians, of course, here, so sine of 0 equals 0. So that's the first y ordinate. So I better write that in, hadn't we? So we've got y0, y1, y2, y3 and y4. So the first one is sine of 0, isn't it? Sine of 0 is equal to 0. Then the next one is sine of a half, and then sine of 1 in radians, of course, sine of 1.5 radians, and then lastly we've got sine of 2. So we need to work these out. We're working to 3 significant figures. So long as we keep our numbers quite accurate, say to 5 significant figures or something, then we should be okay. So sine of 0.5, provided we're in radians mode, let's go to radians mode then, shift mode, radians is 4. So we'll do sine of a half, so sine of 0.5 equals 47943, 0.47942, wasn't it? Dot, dot, dot. So we can just carry on like that. I think that should be fine. Let's get the calculator back. 47942, dot, dot, dot. So let's go back and change this to a 1 now. Sine of 1. 84147, 0.84147. The next one will be at 1.5. So 84147, as we said, then 1.5, 99749, 0.99749, and then sine 2, 90929, 90929, 0.90929, dot, dot, dot. Okay, that's what we've got then. So let's put them in the formula here. So it's a quarter of this one, the first one and the last one. So these two added together. And then it's 2 times the 3 in between. So we'll tap those in the calculator. So a calculation then. So it's a quarter, so let's tap that in, it's 0.25 times bracket the first plus the last, so that's simply 0.90929 plus, and then it's 2 times, bracket the 3 terms in between here, y1, y2, y3, so it's 0.47942 plus 0.84147 plus 99749, 0.99749. Close that bracket, then close the bracket at the end, equals, now it's equal to 1.386, so that's 1.39, isn't it, to 3 significant figures. 1.39, and that was to 3 significant figures.